Welcome to Learner Support Publications. I am Dr. R. Murugan, Associate Professor, Department of Computer Applications, MES College, Maramballi. In this video, we will be discussing Normalization Part 2, Functional Dependencies. Functional dependency. Functional dependency is one of the main concepts associated with normalization. Functional dependencies are constraints on legal relations, and they are the facts about the enterprise that we are modeling with the database. The enterprises can be a library, an administration system, an inventory system, etc. And these constraints may vary from one organization to another, depends on the policy matter of that organization. For example, let us consider an organization which allows faculty members to work only on a single department. In that case, to identify how much time a professor works on a particular department can be identified with the use of the professor name or the professor identification code alone. Now consider another organization which allows a faculty member to work on more than one departments. In that case, for knowing how much time a professor works on a particular department can be identified by searching the professor name or the professor's identification code along with the desired department name or code. That's why I said the constraint may differ from one organization to another. There is no algorithmic method of identifying dependency in a relation. We have to use our common sense, judgment, our experience and expertise to specify constraints. This is a very important topic for the point of view of normalization. If you get the functional dependency basic very well, then you will be easily understand the concept of normalization and normal forms. If x and y are attributes of relation R, then y is functionally dependent on x. If each value of x in R is associated with exactly one value of y in R. This is a formal definition of functional dependency, and x implies y or x determines y holds if whenever two tuples have the same value for x, then they must have the same value for y. That is, for any two tuples t1 and t2 in any relation instance R of R, such that if t1 of x is equal to t2 of x, then t1 of y should be equal to t2 of y. Functional dependency can be diagrammatically represented like this. X functionally determines y, or y is functionally dependent on x. X implies y. Let us consider the department relation with attributes department number, department name and location. Suppose it has different instances. Let us consider department relation with four tuples. T1, D01, Computer Bangalore, T2, D02, Finance Chennai, T3, tuples 3, D03, Research Delhi, and the fourth tuple is again D01, Computer Bangalore. Let the department number is X and department name and location let it be Y. So department number implies or determines department name and location. If T1 of X is D01, T4 of X is also T01. If this is true, then this must be true. T1 of Y is Computer Bangalore and T4 of Y, that is also Computer Bangalore. So if this is true, then this must be true. So department number functionally determines department name and location. Or we can say that department name and location functionally dependent on department number. Here in this functional dependency, X determines Y, the attribute on the left hand side of this arrow is called a determinant, and the attribute or set of attributes on the right hand side of this array is called a dependent. So this is determinant and this is dependent. So determinant can be a single attribute or sometimes it may be a combination of a group of attributes. So determinant of a functional dependency refers to the attribute or group of attributes on the left hand side of the arrow, and dependent the attribute or group of attributes on the right hand side of the arrow. So in this department relation, department number is the determinant and department name and location is dependence. Now let us see the types of functional dependencies. There are different types of functional dependencies: trivial functional dependency, non-trivial functional dependency, partial dependency, full functional dependency, transitive dependency, multi-value dependency, joint dependency, etc. We will discuss the trivial and non-trivial functional dependencies now itself, and the other dependencies will be discussed later when we progress the process of normalization. Trivial functional dependency. In functional dependency, X implies Y. If Y is a subset of X, then X implies Y is a trivial functional dependency. Y can be X also. So X implies X is also a trivial functional dependency. So functional dependency, department number implies department number. So department number can determines department number. And another functional dependency, department number and department name implies department name. See, these are trivial functional dependencies. Trivial dependencies are always valid, and these types of functional dependencies are less used. Non-trivial functional dependency. In functional dependency, X implies Y. If Y intersection X, if it is a null set, then X implies Y is a non-trivial functional dependency. Now consider the department relation again with attributes: department number, department name and location. Department number implies department name is a non-trivial functional dependency because here X is department number and Y is department name. Y intersection X is null set. That is nothing common to X and Y. Non-trivial dependencies may be valid or may not be valid. We need to check the relation for its validity. Sometimes if Y is not a subset of X and if Y intersection X is not equal to null, then X implies Y is called a semi-trivial functional dependency. Consider the FD: department number, department name implies department name and location. See, this is X and this is Y, and Y is not a subset of X, but Y intersection X is not null set. So there is department name is common in both X and Y. So this type of functional dependencies is called the semi-trivial functional dependencies. So in this part, we have seen the concept of functional dependency, diagrammatic representation of functional dependencies, determinants and dependents, types of functional dependencies, and in particular, trivial and non-trivial functional dependencies in detail. Thank you. Thank you for watching this video. In the next video, we will be discussing normal forms 1NF and 2NF.